podcast where the real world meets the digital world as we explore the intersection of spatial computing and AI. Let's welcome our host, Andrew Ballard. Over to you, AB.
Well, g'day and welcome to Spatial. This is episode 18, coming to you from the early part of May. Yes, it's just been Star Wars Day. Yes, I did dust off the Chewbacca suit. That's okay. That's a story for a different day. Welcome again. I'm joined here by Mirek Birkin, our robotic expert,
Hello.
Mechanical expert. How are you faring? You good?
Hello, how's everybody doing?
Good to see you. Look at that background. For those who are listening only, yes, this will also be a YouTube episode. It is also a readable on our blog, so any medium that you wish. In fact, it might well be on Medium as well. Doing the classic thing of you can choose your format. Today's episode is actually going to be a one-on-one. We get the absolute pleasure of picking Mirek's brain topic. If you've already seen the episode title, it's on the icon. We're going to talk about ROS. ROS is the Robot Operating System. It's a relatively standard, stable, it really is the go-to for a lot of robotic open source projects. But here's the...
But it's complicated.
It's complicated. That's probably the one-liner of the whole thing. It's powerful, it's phenomenal, it's used in a lot of places. But let's just say that the first step is quite a doozy. There's a lot to learn. We were just having a chat as we were getting our mics tested. You know, those old board games of, a minute to learn and a lifetime to master. ROS tends to be a little bit more in the a fairly long time to learn and a few lifetimes to master. No slight on the devs and the team trying to put it in place. It's not overly simple and they're not trying to do it in a simplistic fashion. It is quite a powerful tool set, but it needs some explaining, and that's why we're here. Mirek has been, he's actually been quite quiet on the internet for about 12 months, even 2 years.
That's because I've been learning ROS. That's why.
Gotcha. Before I knew it, you were a 21-year-old and you had grey hairs with paint on every morning. Yeah. To be serious though, I've known you for definitely 2 years plus, but you've probably spent 12 months kind of in self-imposed hibernation / isolation. You've got head down and you've been really going through this knowledge that we're going to pick apart now. So Mirek, what's your summary of the ROS system? First of all, it is ROS, I take it, not ROS. There's only one S. That's what the community is happy to call it.
It's ROS. People call it operating system. That's what it's kind of coming into it. That's what you expect, but it's not really an operating system in terms of Android or iOS or anything like that. It's more of a framework and a messaging system and a middleware to have multiple parts of your robot talk to each other. And it's really complicated. The learning curve is very steep. I think I mentioned this on this podcast quite a few times. There's a bunch of reasons why you wouldn't use ROS, and that's where you say have a simple machine that everything you program happens on, say, Raspberry Pi, and that one board is perfectly fine to read some sensors and drive some motors. And if that's all that you're doing, then you're fine, and you would completely. You wouldn't make your life easier with ROS. Gotcha. if you're doing this sort of thing. Yep. ROS is more of a design infrastructure and lots of code and lots of best practices for systems that are slightly more complicated than that. Say you have multiple boards or even multiple configurations of a machine. Different parts of hardware, in different versions, you're iterating on something. Yeah. And instead of one monolithic piece of code, you have nodes that do specialized things. Say you have one node, like a piece of code, piece of application that reads your battery level and broadcasts that information. And then you can have another node that reads instructions for how to drive the motors and sends those signals to your motors. And there's bits of logic behind this that sort of takes into account maybe your battery status, but maybe most importantly where you are in the scene, where You're trying to get, and translates that into signals or data for these particular nodes. And this is handy when you then replace your motor. You don't need to rewrite the application. You have this isolated piece of code, say a driver, that just comes and goes. And in terms of ROS, it's pretty much something that is supposed to run on any hardware configuration, any machine. In actuality, it runs on specific flavors of Ubuntu and specific distros. So you sort of begin this whole process by setting up an environment for ROS, which could be running on Linux, or it could be running on a microcontroller, and then talk to the rest of the system through this other subsystem. That makes it easier. Believe it or not, it's actually much easier than to not have this.
Okay, so there are some guidelines. There are some please dos. There are some suggestions, but essentially it starts with a cookie cutter of here's a bare bones ROS install. You get a VM, you get a package, or you start on bare metal.
You usually start with the tutorials that get you so far as driving a simulated robot, like the simplest form of a robot that, in this universe is usually a turtle bot. It has two wheels, and some sensors, and you can drive this robot around, click on somewhere on the scene, which is giving coordinates to your simulated robot, and then it responds to simulated sensory input. This can be also done on real metal, but it's just much easier to start in simulation.
Nice.
So you start with that, and usually you watch tons and tons of videos and read tons and tons of documentations. And most of the time, people trying to show you what this is about go into great detail, just installing something and configuring something for 40 minutes, which is tedious to watch. But that's mainly your experience. Like, you get tons of code and instructions and best practices and how-tos, but then there's code that sometimes is documented really well. Sometimes the only documentation is the code itself.
Okay.
But it's still so useful to you than, starting from a blank page, that it's really useful to just dive into it, take the time, and then figure out how to configure this particular piece of logic to work with your hardware.
Gotcha.
Which is what you're doing most of the time. And as you dig into it, you figure out that, this code does almost what I need, but you need to be ready to modify that, to dig into it and just, follow where the other person left off, because this is an open source ecosystem. And the people come often into it and expect a polished product. But it's a community of people, and sometimes somebody shows you, this is how I do it, and it's up
convenient,
to you
but it's messy,
to make
or
most of it.
Yeah, gotcha. Half handy, but actually can also take you off track because it goes down their solution. Excuse me. The entry, the bar for entry. So the hello worlds are completely virtual. I take it you don't need hardware until you need to actually go and purchase hardware. You can still do a lot with driving virtual boxes on virtual screens. That's still valid, is it? Or is it really start to get gnarly when you do start to get into the interfaces with physical hardware and drivers and sensors?
It's definitely valid, and there's a bunch of things that come with this packaging. And one of them is the way you describe the robot to your environment, which is something you need to do if you want to do some inverse kinematics, right? Or if you have joints on the robot that move in a certain way, or if you're just reading some sensor data and you want your robot to prevent from bumping into things, you need to have at least some scale of how big the robot is.
Gotcha.
So the description in the ROS ecosystem happens in a format called URDF, Universal Robot Descriptor File, which is an XML file that you use to pretty much describe your machine in terms of joints and frames of reference, and this is where my sensor is, and then this helps you to do, the translation of that reference frame to where you actually want to have your information sort of projected. ROS also comes with a simulator engine, or two that I know of that are widely used. So it helps you to sort of get things done faster than you would have to when you're also iterating on hardware. That sort of introduces even more complexity, but helps you to keep things separate. And as you're digging into this universe, you're discovering topics that you didn't know existed, but in ROS it's a whole separate sub-operating system, you might call it. There's
flavors
this
of the whole
subsystem
framework?
that there are separate initiatives that are, say, the control system that you want to drive a robot, and so you need to translate your desired velocity into the model of the robot. Say your robot has two wheels, one on each side, and some coaster wheel. That's what the turtlebot is. That's the simplest form that we use. So even that, you need to do some simple math to translate the velocity vector into speed of each individual motor.
Gotcha.
So there's a driver for that, and you don't need to think about it. You just tell this particular node that your wheels are this diameter and this far apart, and then it does all
the
that
math
for
is
you.
there for you, right? Yeah.
But there's not drivers for all geometries. You can have a legged robot, and there's a driver for that, or you can have something slightly more balancing robot, right? But it doesn't come optimized for your hardware. That's sort of your job to do that.
And we can see in the background of your screen, and we'll have a link in the show notes, that's actually a ROSbot, which is ironically and correctly named. That's a small four-wheeled buggy, which is basically a lovely platform, excuse me, which is perfect for the ROS operating system, entry-level pre-bought to find, it's a step up from the Turtle bot. It also has a lovely hardware attachment at the top for all sorts of cameras, LiDAR sensors, a whole lot, which I can see you've pretty much pulled apart and you've got your own stack. Is that ROSbot, is that well known, and that's like described with plug and play files, and there are some plug and plays for other known robotic platforms, or is it pretty much everyone will be bespoke, different, and have to roll your own?
So this is just one example of what you can get as the next step if you don't want to build your hardware, because it might be a little too much, really. So you might want to get something. That's what I did. Just learn everything about it and take it from there. It helps if you know a little bit of electronics. It definitely helps if you understand software and Linux, because this is, that's most of what it is.
Yep.
There's few machines like this, development kits that you can get. This one was 2700. It's from this Polish company, Husarian. This is their dev kit that you write your software for, and then you can upgrade to their much bigger machine that's ready for industrial use. Or you can just customize the thing and build the next robot yourself because you've learned enough. The internal workings when it comes to ROS tend to be pretty standardized, but each machine is different. And pretty much what each company does is this wiring. They either, this comes with a LiDAR that is a product of another company that packages it with a ROS driver.
Brilliant.
So that ROS driver comes included in this machine, and it's configured to work together. Everything's wired properly, both in terms of hardware and software. But if you're building your machine on ROS, this is exactly what you need to do.
Yeah, gotcha.
So it helps to start by following somebody else's examples and best practices and maybe worst practices, but it helps you to sort of get some sense of how this works, because then you pretty much get some compute module, some actuators, battery, wireless module, and you're good to go, and you can start building your own version of whatever you want to work on.
Nice. Now, this is open source completely. Is this any of the model of other open source software platforms where there's the open source version and a premium supported version, or this is purely community driven?
This is all open source, and it's open source, like I mentioned, to an extent that you kind of expect it to read the code and write the code and modify the code.
Right. Okay. So the expectation is that you'll actually give back your solutions back into the fold. That probably, I think you've actually mentioned it before a few minutes ago, but that also means that the, let's say, the variability of tutorials and code is pretty high. Is there a core set, or are there some leading lights who you would almost always follow, that some tutorials by certain users are just gold, they're the ones everyone flocks to, or there's just smatterings of goodness and badness across a wide variety of users?
There's a bunch of good stuff on YouTube, definitely, and other places, I'm sure. It tends to be, when it comes to ROS, like long sessions of somebody showing you how to install a package and compile it with another package, and all that.
Which them pull their hair out.
Yeah. So it's little. You really need to take the time to sort of absorb this.
Yeah.
This kind of stuff, because most of the time the person is just showing you their best practices and oh man.
Yeah. Now, winding all the way back to one of your first comments, this is a modular framework. Now, modular is obviously, compared to the example of if you just need a gate moving or a latch or something, a Raspberry Pi has enough I/O, enough inputs, outputs to be able to wire it up to many things, and it can be used for things that get a bit more complex. But the ROS system implies modularity, which is basically ready for upgrading your robot or switching out something for something else. Or is that modularity, obviously that's almost one of the central patterns, that's one of the central things about it, that it's supremely powerful, but you distribute that logic in so many places, that's quite a large task to just get started. Is that the vibe, that it takes a long time to get everything in alignment, but once you are, wow, you can really code fast? Or it's always a sort of a slow step by step, a bit of a slog? Do you reach a plateau where suddenly all the doors are open, everything's wired up, connected, and suddenly you can just be coding and things magically happen beautifully? Or is it always a little bit of a shuffling and struggling?
I've heard of companies who decided to not use ROS, and the reason was that it's just too difficult, and they want to go fast, and this is just too slow. But as I dived into it, I learned and I came to believe that it actually helps you to separate tasks, and you only really need maybe one strong ROS engineer or guru in your team, and it helps to actually split tasks within in a group of developers.
Okay,
and
so
sort of isolate them and communicate in sort of standardized way. That's, you don't have to invent your wheel there.
This is the glue. This is the integration between other coders doing perhaps logic and sensing and drivers. This is the comms between all those modular units.
Yeah, and it goes even, it touches things like coding style, which is an issue when you collaborate with more people. So in ROS, you can write code in C++, and or Python these days. And since your bits of functionality are isolated, you can have a person writing Python code that then talks to something that's in C++. And it's not an issue. And it runs on the same machine. There's even... Sorry, I'm thinking of Docker now because I wanted to mention Docker. Docker is, you might, it's really hard to, you might need to edit this.
That's all right. There's a translation engine so that Python and C can live literally side by side.
So you can have multiple people work in isolation on their respective tasks, and be sure that these bits will talk to each other. And a big help with this is Docker, that is quite common in the ROS universe also. Docker is this container engine that allows you to sort of isolate pieces of logic within its own environment, say in one Linux host machine. And you would achieve this with virtualization, but this is not. It performs much better if you're not simulating, virtualizing different kind of architectures. So there's very little cost in terms of performance. but it allows you to ship your code in terms of these individually isolated building blocks that still talk to each other and can live on one piece of hardware, say, one Raspberry Pi that drives your robot, or they can be distributed over this local network that consists your robot. If you have one board that does video processing or some AI stuff, and another board that does your navigation, and you still want these to talk to each other, you can do this in ROS very easily, and that's pretty much the biggest benefit of this kind of architecture. And you definitely get a lot of overhead in terms of, this wouldn't have to be this crazy complicated from day one, but you will appreciate it if you iterate on your hardware, and then your robot's brain is not this huge monolithic spaghetti monster. It's more like, little spaghetti monsters, and everything in principle talks to each other.
Gotcha. Now to go the other extreme and asking a suggestive question, is ROS a bit too purist? Is it a little bit too over elegant, or actually is it architecturally? Is it actually a perfect theory? Just the practice does kind of hurt a bit. Are they doing lofty and correct goals, and it's just hard work to get there?
Yeah, I've been thinking about it a lot, and I don't know. I think
you have dreams, nightmares.
There's definitely some cost of complexity in that complexity.
Yeah.
But also, I think on this level, like being this close to metal, I think is justified. So it's like coming into this ecosystem, you'll read about how ROS should run on anything, and then it doesn't. Or it should work with any Linux distro, and then it doesn't.
It doesn't.
And it's just complicated. But that's not the point. Yeah. Just grab the best example you can get, and follow those recommendations. It's not one product that would come in a box. It's this amorphous blob of useful tools. I think it's so there's this complexity, and also there are some I would say, like you might expect. Sorry, got something in my eye. Damn it!
I'm hearing that tension between purist, elegant, beautiful theory, and gnarly, painful, but it feels good at the end. Is that the intent of the ROS core coders to keep you on a good track, even though this pain is actually worthwhile? This is not that there's no other ways I know of apart from, and I'll go dead simple, the Lego operating system for playing with robotics. Beyond toys, you actually do need some level of rigor. This feels like the first step of hammering that rigor into you is well worth it, asterisk, but gee, it hurts.
I don't think it's purist versus not purist. I think it's just what it is, given where we are with ROS development in time.
Gotcha.
And most tools, and that was quite shocking to me, that come in this ecosystem are very difficult to use, like way more difficult. And that's a different thing from this whole concept or, architecture of ROS. And there's tools that come with it. And most of the time, your mileage will differ, will vary. And I think that can improve. And better tools can give you better insight in what's happening in your system. And all this pain of, like I keep mentioning that in theory ROS should run on anything. It kind of does, but it kind of doesn't. So if I'm moving to the industry, do I need to drop everything and start working on Ubuntu Linux because that's what it runs on, right? Or maybe you don't have to. We just need slightly different tools, and it's gonna be much less painful. And anyway, I'm rumbling.
All good. Easy question for you. A softball and a way to be cathartic, if I need to, for you. How are you using ROS now? What's been your journey and your struggle and your end goal? You know, is the end in sight? I know you were hesitant to even talk about ROS because, you know, I'm not a master. Well, that's perfectly fine. Everyone stands on the shoulders of giants, and we're going to pick on your shoulders now to give us that first lift too. But yeah, your journey, what's your goal for ROS and how far are you? Is there a completion, or is there always one more thing to be done?
Oh, there's many things to be done, but there's also some light at the end of the tunnel. So I came into this by looking at how I can interact with robots using augmented reality, which means seeing all sorts of data, producing all sorts of data, sort of communicating with the machine in some standardized way. And so how do you do that, right? You have to... I can't plug my tool into just anything. There needs to be some communication protocol. So I chose ROS because, like you mentioned in the beginning, it's pretty much an industry standard, but you know there's plenty of good reasons for not using it. But if you're trying to cover as much of the industry as possible with something that you just want to plug into a machine, no matter what the machine does. That's why I chose ROS. And it works with, you know, robotic arms as well as self-driving delivery bots and drones and all sorts of things. So it covers really colorful variety of machines, but the underlying principles are kind of the same. And the code you can often also reuse. And once you understand how to do this particular thing, then doing something slightly different on a different machine is just a little bit different. It's not, you know, you're not starting from scratch.
Yeah, gotcha.
And yeah, my first idea was that I would just take this messaging system that ROS is and connect it to a headset, but that turned out to be rather difficult.
Okay. That was the first 6 months.
It took a while. Because ROS can run on various machines, but the discovery of the nodes is kind of, it happens, it does it automatically, but you don't want to do that on a public network, which is where you are when you're, you know, connected to a Wi-Fi and your robot's connected to a Wi-Fi. You don't want to just publicly stream everything and open your robot to just anything. So, and also what I've encountered is that just using the network protocols that people use on local network doesn't really use when you want to, you know, talk to some other system that is not necessarily part of your robot. So what I've done is I've made this ROS node that sits on your robot and provides this streaming capability via WebRTC, which is what we're using to stream video and audio. It can also stream data.
Yep,
and
so
it does
packet-based.
And it does it using UDP protocol, which means you're purposefully losing packets in favor of speed. Okay. And you can stream video, you can stream data. And what I'm doing also is, you know, sort of optimizing the data before I send it to you. And it works both ways. It can also receive packages real fast. So I'm driving the robot remotely using the very same system. It's going to be a product. I think it helps people to even, like I mentioned it, that I'm pretty much building what wasn't there. So there's a bunch of features that help you understand the data flows within a complicated system like this. You can see the nodes and what data they produce. You can subscribe to each channel and see what's going on. You can have, you know, data visualized. If you have LiDAR streaming you some data, you can see in real time what that's producing and, you know, mesh it with other data and drive your robot remotely. How cool is that?
Wow. Oh, look, very cool. That's something we definitely would love to follow up on. We might need to do a YouTube-only episode where we actually get a working demo. And is this the kind of thing that, drive the Smithsonian robotic arm from a distance kind of thing? Or are those more hard-coded and bespoke? This is a kind of a over-the-air internet is handy, but I dare say the networking and the security protocols would be coming into play somewhere about now.
Oh yeah, well, security is one thing I'm leaving for later.
Down the road.
No, it's pretty secure. But it's pretty universal. Like you can drive a robot on wheels, or you could in theory drive an arm with that. And it's sort of, I've been using this tool. I don't want to brag about it right now because it's like I'd rather present it when it's done.
Easy.
But it's a pretty universal tool that sort of takes ROS for what it is and sort of takes the scope of it and builds on top of that, and adds some features like web interface that you can connect Bluetooth controller to and then drive your robot without doing anything to the robot itself. Like it's that compatible with this whole ecosystem.
Wow. I take it scale is possible because of this. We're talking swarms, we're talking streams, we're talking masses of robots. Is doable, or that actually has to be coded, networked, and organized and optimized when you get into beyond one or two? Is that a built-in factor of the ROS system that it natively can handle any number, or that is another decision that you have to do some work over the top of?
You need to do that separately if you want any kind of swarm behavior, because ROS pretty much deals with your hardware, and this high-level logic is, if it's coming from navigation, if it's coming from some state machine. If it's coming from yet some other place, you might want to stream it via WebRTC maybe into the machine, like you would.
Is there a concept of a ROS module that is the brain, that is the central logic unit, or that itself is your own code elsewhere that just connects into ROS? Is that's embedded into a module?
Yeah, I would consider like philosophically this whole thing to be the robot's brain.
Yeah. You were not going to grab out the scalpel, but yeah, gotcha. So there's no direct module ready for this is the place where everything comes to. It's just a stateless modular framework of comms, and then you can join them in any which way you want. And many people would join them in ways that might have similar patterns. Like you've then saying you've got the module that is your central hub, which obviously then is probably the place where you'd want to then bounce in your heads-up displays, your augmented reality overlays, and data back and forth, and controlling back and forth. That's where the human would sit in that particular loop.
I mean, your central brain could be a simple Python program that sort of takes into account what's going on and on some, simple level decides what needs to happen. Or even it could be a distributed thing. You can have a robot that sort of, has wheels and an arm, and at some point you may want to switch control.
To go there, tells the motor, I want to go there. Yeah, gotcha. So it can go down the hierarchy and figure out, there's not one brain.
Things are happening at the same time, and sort of, taking into account what's going on in a different place. And
now, when you said that some companies actually take a good hard look at ROS and then decide, in Australian terminology, and just nope out of there. If they're building their own thing, or if they're choosing a different thing, are there, by all means, we can name names and we can throw links in the show notes, are there commercial ROS-like operating systems out there? Or is it just, if you want your own thing, it's because you've got your own hardware, you just do bare metal logic, like you bind the software to the hardware? All this elegance, purity of modular and making it extensible is lovely, but if you know what hardware you've got, you just code for that hardware. Is that the delineation that some of the commercial companies are making, or are they running to another platform?
Sometimes you choose hardware because of the software it comes with in this world.
Okay.
And I think the most prevalent other solution would be to just write it from scratch and use
Just
whatever
linking cursor,
libraries you can,
line one, position
get
one.
and just
Gotcha.
just put things together as you go.
So a
And there's
traditional
definitely a
software
bunch of-
project based around your hardware.
Yeah.
Gotcha. And companies make that choice based on how bespoke they're going to be, the strength of their software teams. But then on the flip side, a solo developer like yourself or small teams or people who know they're going to be iterating, that's where ROS really starts to shine.
I think it's worth it to go that route, and I think people don't do it quite often. I'm not arguing for ROS. I totally get like that it's overwhelming, and I'm still
I used the
overwhelmed,
ROS
and I've
shell.
been for a while.
Just
But
big ROS.
Quite often, what happens is that you're dealing with a problem that is, I don't know, as simple as differential driving, right? A robot with two wheels, whatever. And you need to figure it out. You go to Wikipedia and you study the math, and then you produce an algorithm while it's been sitting there on
It's been done
in the ROS history forever. So this can get much more complicated. Like when you start dealing with navigation and autonomy and all sorts of computer vision topics, then you simply can't reinvent everything that you can't start from scratch. It's just too much. So I believe what's often the issue with ROS is that it's just so overwhelming that people don't have the patience. And then, when you kind of know what you're doing with your product, you come back and maybe you rewrite everything you have because most of it is done somewhere else, and you just need to reorganize your code and configure a bunch of other stuff that other people wrote.
Gotcha. It's that age-old question of if something is off the shelf, even ROS or not, what benefit is it giving me? If it gives you 80, 90% for free and just the last 20% is your own blood, sweat and tears, that's a victory. That's great. But if you get only 10% for free and the rest is your blood, sweat and tears, that 10% head start might actually cost you in time and effort to refactor and comment out and sort through. So trying to find that inflection point where it's going to give you enough of an oomph and a head start once you overcome that steep learning curve versus... is there a... I love the fact that there's the Hello World, the virtual tutorials, which is really good. It means you can just walk up to it, download it, install it. That sounds like that's a good evening anyway. But get started without buying hardware. But is there a logical next step? Is there then the number two thing, the Hello World 2 that people tend to do? The ROSbot, the physical the four-wheel buggy there in the background. Or is this pretty much the thing that a university academic might do, that I have built my own robot, I don't want to do the software, I'll only spend, 50 evenings trying to figure out the ROS operating software so that then I can bolt on the software to what really is my thing, which is the hardware. Is it the go-to default operating system if you're a hardware specialist versus is it a software tool for software people who happen to be into hardware?
Oh, that's very philosophical.
I know. Sorry. Is it good? It seems to me it's the correct software tool for most applications, and it solves people's hardware problems when inevitably the hardware gets better every alternate year, and you change your mind and you get a better this and a bigger that.
Here we're kind of in the process of integrating hardware and software together. So it's on you, really. If you're in robotics, I assume you want to build some hardware or maybe write software for robotics. And in both cases, I think it's useful to go the ROS way, simply because other people who know ROS and spend the time can help you with that. It becomes even easier to work on more complex projects. I don't think it's just an academic thing. It started as that, but it has real world benefits, for practical engineer.
Yeah.
Rumbling again.
Definitely can't end this episode without getting your thoughts on the amazing bit of video that happened, probably about 2 weeks ago now. Well, actually, it happened over the course of about 3 days. Boston Dynamics released a video saying that Atlas was retiring. That is the one that does all the yoga, the dancing. It's the humanoid size shape robot built on hydraulics. Phenomenal. It's progressed from DARPA four-legged into, well, granted that was Spot, but watching the progress of these robots over many years. And ironically, about 2 days after they said we're announcing the retirement of our Atlas robot, hey, we're going to show you the first demo of our new Atlas robot. Love your thoughts on the electric motor version, 360-degree bending, Pixar face looking like robot.
I love the design and love the presentation.
Yeah,
I think they did that. You're referring to when the robot stands up and
finds its own way to pivot the hips differently to the head, and the whole torso rotates underneath itself.
I see how some people could be disturbed by that. I love it. I don't think that robots need to look exactly like us puny humans. So that's exactly what they're doing. They just want to be like this little
showing off its strengths immediately.
Just a little bit unsettling, but I love the design.
Yeah. Are they? Does Boston Dynamics use ROS anywhere in their stack?
Oh yeah, absolutely.
Okay, brilliant.
And I mentioned URDF, as the description of the model. You can get all of that from Boston Dynamics for free and use it in your simulations.
Right.
And then, just get the hardware if you so desire.
Right, sure. Just, let it be known that a project that we were both working on, I did get a price list for Spot Dogs with all the trimmings from Boston Dynamics. Sadly, it had a few extra zero that was a bit too much, but that's okay.
It's the same with the cheaper dogs. With Unitree also runs ROS, but they're a little particular about their license policies, so they don't want to open everything to you unless you pay them more than what you expected.
Okay.
So but it's ROS. It's ROS underneath.
ROS based. Gotcha. Customized or just with some proprietary or just under a layer of protection so that you can't directly tinker?
It's all kind of customized.
Okay, well, ROS is custom.
Like never ends up in a product as you would just download something from the internet.
Gotcha. Yeah, gotcha. This is the framework versus, as you said at the very start, it's called an operating system, but it's not what anyone would actually call an operating system if they had the chance. In fact, ROS with the OS at the end, I think more people would also just think about it as being the OS standing for open source. So it maybe is like a recursive. Like isn't PHP stand for the PHP Hypertext Protocol, which is a recursive acronym? ROS is more known for being open source than, I guess, an operating system. But an ad or a one-liner for what you've been working on for many years, you are actually working on an, I'll call it always, an operating system, a way for a human to walk up to a robot and, hey, you go here, do this, that kind of thing. That's more the mouse point-click folder system that we know and love of our current systems.
Yeah, but even that, can be only so abstract. And
Gotcha. It has to hit the ground it has to reach out to reality at some point. Yeah. No, I love it. Mirek, thank you. Great intro. There are people who probably have taken a look and turned away. I know I've not needed to get into it, but I've delved around the edges enough to know that that's for a cold, long weekend in the middle of winter. Actually, I tend to do in this part of the world, the Tour de France goes for 3 weeks in the middle of winter. Perfect for doing a few coding projects on the couch while you're half watching the cycling race and watching everyone else in high summer. It has been on my radar to do one day, but I must say there's never been a hardware project. But I love the fact that can start with completely virtual in the simulators, and that's enough without having to spend big dollars on big hardware, batteries, motors, the whole lot. So I must say I might actually open up one of those VMs, spend the evening downloading it, configuring it, and see if I can get a turtle to walk across the screen, he says, as I have a turtle behind me making noise. It's something that's on my radar, but it is something that I think a lot of people have had on their radar, had a look at like me and decided, oh, that's not for me. So as I say, great to have a set of tutorials that is there for starters. I'd love to take you up on the offer one day of actually exploring your code, running through your hello world in your scenario. Sure, when your code is full of less expletives and more comments and, the demo is guaranteed to run rather than fingers crossed and hope for the best. That's cool. That'd be great.
Definitely will do that.
All good. Also, really for anyone coming up, learning students, programmers who are wanting to get into the field, by the sound of it, it is the industry standard by which others are compared. In that regard, as a de facto standard, it's good to know, even if you don't have any illusions of I want to be in it forever. Like most software tools that are predominant, you want to have assessed them to kind of get a feel for how hard it is, where some strengths are. So even if you are completely passive and you just watch many of the YouTube videos, we'll put some links here in the show notes. Just absorbing things is actually a great start. It's good to get over that first hump as fast as possible, even if your fingers don't start typing brand new code. Just to absorb where it can shine and where it's a little bit less than adequate, where that line is between Raspberry Pi and ROS. Parting thoughts. I take it the community of ROS is very strong but highly variable. There's back channels, there's Discords, there's forums, there's the whole kit. There's always someone up who's having the same problem as you. Is that always an option?
Most likely, yes. And people are very helpful and friendly.
Nice.
Which is not so common on the other parts of the internet. But it's very no nonsense and
Brilliant. Yeah.
helpful community. So
Having a positive start is good when the software is hurts your brain anyway. It's nice to have real people who can kind of help you. I take it the help stops at a certain line because it's like, I don't know what you're trying to do, but I think you've probably got some problems in this area. It's probably always non-specific advice. It's general advice. Is that the normal trend? Or people can actually read your code verbatim and give you some better guidance?
Nobody's going to read thousands and thousands of lines of your code. Like, don't expect that. But if you can describe your problem, people will help you and point you in the right direction. And I wouldn't be afraid to ask because it can be overwhelming. And most of the people who are, part of the community went through the same process and know how overwhelming it is.
In your seat, exactly. Apart from, is there a core who does the development, or as you say, you're expected to push back and submit code to the next releases? Is it? By all means, I love the alphabetized release versions. Is it seriously progressive, or is it regular cadence? Is it a little bit leading edge, bleeding edge? What's the actual code release?
Code gets released all the time, but only every now and then it gets packaged to a distribution. It's like pretty similar to your Linux distribution cycles, and it's pretty much the same process in how the code comes together. So you can contribute with your own code. It's not gonna be probably retroactively applied to the whole history of ROS because there is a lot of history. There's different versions that sometimes work together, sometimes don't.
Specific breaks where you need to push forward and never go back if that's the case. Yeah, okay. Yeah.
There's an organization that sort of maintains the code base, and you can read all about that and be part of that. Yeah, but that's where you seek help also, is these community forums. And, people sometimes get paid for their work, sometimes they don't, and they just, engineer like you trying to figure something out.
Yeah. Legendary, Mirek. Thank you for letting us stand on the shoulder of the giant that is you. So thank you for that. Great to get to brain dump. I really do wish we ever had the Matrix style injection of everything we need to know by, I don't know what their technology was, cartridge, I think it was. Anyway, it looked like a zip disk back in the day. Probably was. Until then, it really is getting those insights is quite invaluable. So thank you for that. Struggle on, power on. We definitely look forward to some serious demos and look forward to an update on how the operating system over the top of the operating system is going. We'll definitely hold you to a workable demo whenever you're ready for it. But I know you've been in the weeds of this for a fairly long time, so it's great to hear that there are some lights in the tunnel and it's not just, what is it, the freight train about to hit you. So well done for punching through.
Yeah, we'll definitely do that.
Legendary. Well, thank you all. Cheers for that. We'll leave it there for episode 18. So this has been on all channels. You're either listening, watching, or reading. Transcript has always been a bit funky. And now there's, in fact, the podcast channels are offering their own transcripts. So we'll let the competing AIs figure out what we're saying. Good, clean fun. Thanks for that. We'll catch you on the next episode of Spatial. But for now, bye-bye.
Bye.
See ya.
If you'd like more news and insights about spatial AI, or have a story or interesting topic you'd like us to cover, reach out to us. Or better yet, come and join the community at Spatial. All the links are in the show notes.